If you're a student or beginner trying to understand IT, information systems, or programming without the confusing jargon, welcome to LD Tech Lab. Make sure to subscribe, and let's break this topic down step by step.
All right, let's talk about something that drives every new programmer absolutely crazy. You know the feeling, right? You've written your Java code, you hit run, and no errors. It works, but it doesn't do what you want it to do. Today, we're going to solve that mystery. We're diving into the world of logic errors.
Sound familiar? I bet it does. This is probably the #1 thing I hear from people just starting out. It's that moment where you're staring at the screen thinking, how is this possible? The computer isn't broken, and Java isn't trying to trick you. The puzzle is actually in our own code.
So, who's the bad guy in this story? It's not a typo. It's not a missing semicolon. The culprit is something way sneakier, something hiding in plain sight. A logic error. We're not talking about the grammar of your code anymore. We're talking about the meaning of your instructions, especially inside those all-important if statements. So what exactly is a logic error? Well, it's when your code is technically perfect. The Java compiler looks at it and says, yep, this all follows the rules, you're good to go. But the instructions you wrote, they don't actually do the job you thought they would. It's kind of like giving someone perfect, step-by-step driving directions to the completely wrong city. The directions work, but you're not going to end up where you wanted to go. And this right here is the absolute heart of the issue. You have to remember, Java is like a super literal genie. It does exactly what you tell it to do, not what you meant to tell it to do. It can't read your mind. So if your logic is flawed, even just a tiny bit, Java is going to follow that flawed logic perfectly. Okay, let's put on our detective hats and start with the #1 offender. Seriously, this is probably the most common logic error for beginners. It's a tiny little character that causes a massive amount of confusion, the equal sign. Okay, this is so important. A single equal sign, equals, is a command. It's an order. It says, hey Java, take this value and assign it to this variable. Make it so. But a double equals sign, double equals, that's a question. It asks, hey Java, is this thing on the left equal to the thing on the right? Yes or no? One is an action, the other is a comparison. Mixing them up is a recipe for disaster. And this is where it all goes wrong. You see this all the time in beginner code. In your head, you're asking if x is 5, but what you've actually written is a command, make x equal to 5. An if statement needs a true or false question to work, not a command. So if your conditions are acting weird, this is the very first thing you should check, always.
All right, we've cracked the case of the equals sign, but that's not the only trap waiting for us. Let's move on to our next set of clues and see how just misunderstanding some other basic operators can completely mess up our logic. You know these guys, right? There are basic tools for comparing things. Greater than, less than, not equal to, and so on. They all ask a simple true or false question. Is the score greater than 90? True. Is the age less than 18? False. Seems straightforward, but oh, the devil is in the details. And this is a perfect example. Let's say you need a 75 to pass a class. So you write a condition that says score greater than 75. What happens when a student gets exactly a 75? Well, is 75 greater than 75? No, it's not. So your condition is false and they fail. You meant for them to pass, but you told Java that only scores strictly greater than 75 are good enough. The computer isn't wrong, our logic was. Okay, this is another huge one. Think of the AND operator, and, like a really strict bouncer at a club. To get in, you have to be over 21 and on the list. Both things have to be true, no exceptions. But the OR operator, or, is way more chill. You can get in if you're over 21 or you're with the band. Just one of those things needs to be true. Mixing these up is an incredibly easy way to write code that looks right but just doesn't work. Let's crank up the difficulty a little bit. We're going to look at two slightly more advanced traps now, creating logic that can literally never happen, and a really weird quirk with how Java deals with text, which we call strings. Okay, take a look at this. Just read it out loud to yourself. If age is less than 18 and age is greater than 60. Wait a minute. Think about it. Can any number, any single age, be both of those things at the exact same time? No way. Of course not. It's impossible. This is what we call an impossible condition. It will always be false no matter what. So if you've ever written an if block that just mysteriously never ever runs, you might have accidentally created one of these logical black holes in your code. And here we go. This is a classic welcome to Java moment. You'd think you could compare two pieces of text using the double equal sign, double equals, right? Wrong. In Java, when you do that with strings, you're not actually checking if the text is the same, you're checking if they're the exact same object in the computer's memory. The right way, the only way, to correctly check if the words match up is to use the dot equals method.
Okay, enough problems, right? We've seen all the common criminals. But how do you actually find them in your own code? The answer is, you need a plan. When your code isn't working, don't just stare at it and guess. Let's go over a simple 4-step playbook you can use every single time to hunt down these logic errors.
Let's break this down. First, literally read your if statement out loud, like you're explaining it to someone. Does it even make sense in English? Second, stop guessing what's in your variables. Just print them out right before the if statement so you can see their real values. Third, if you have a long condition with a bunch of ands and ors, break it down. Test each little piece on its own to see which part is failing. And finally, when you're writing new code, start simple. Get one condition working, then add the next layer of complexity.
So, if there's one thing you take away from all of this, let it be this. Your code runs but doesn't work because Java is a perfect, logical machine. The challenge isn't getting Java to understand you. The challenge is making sure that the instructions you tell it are a perfect match for what you actually meant to happen.
So now it's your turn. You've got the tools, you know what to look for. Go take another look at your own code. That one frustrating bug that's been driving you nuts? It might just be one of these simple logic errors hiding in plain sight. So the only question is, which one are you going to find first? Happy debugging!
If this video helped you understand the topic better, please like, subscribe to LD Tech Lab, and comment below what you want to learn next. Your questions help shape future lessons.